Hey guys, so it'll probably be a really quick video. So we're doing alcohols. Now again, I'm following the Kaplan books, even though I personally don't agree with alcohols being 1.2 because we go over alcohols in 1.5 as well. I mean, sorry, not 1.5, in chapter 5. So for now, I'll just call this the intro. And in chapter 1.2, Kaplan quickly goes over a few things about alcohols. So we're just going to go over them as well. It should be a very quick video. So pretty much what is an alcohol, right? So we know an alcohol is a hydrogen bonded to an oxygen, right? And then we know it has the prefix OL. Now, one common mistake that people do is when you have this is no longer just an alcohol, right? This is a carboxylic acid. Okay, so make sure that you understand when we talk about alcohol, we call these free alcohols, okay, meaning that they're not bonded to another group. Awesome. So now that we know that, you also need to know alcohols are very good at making strong hydrogen bonds. So remember, whenever you have a really electronegative atom, aka we're talking about fluorine, nitrogen, and oxygen connected to a hydrogen, um, you can make hydrogen bonds, and alcohols they're very good at making hydrogen bonds. So there's a few reactions of alcohols you need to know. One of them being hydration. Um, we can go over this mechanism really quickly. So it really is just the addition of alcohols with OH. So we have H2O. We know that this pulls away, so this is slightly negative, making this carbon here slightly positive. And we can prove that by drawing the resonance structure here. Hold on, I need to give myself more space. Yeah, that would happen. Okay, let's just do this up here. So we have this, and then again, this reaction is reversible, and we went over what that meant in the first video. So if you have H2O, we know that this is slightly negative, making this carbon slightly positive. And another way we could show that is by drawing the resonance structure. I'm going to do this in a different color. So you see how now this is a positive charge at the bottom, and then this oxygen now has a negative charge. So that positive charge here allows us to do a reaction. Negative goes to positive, and we know that oxygen again is slightly negative, and if this is slightly positive, then this bond is going to go here, and this bond is going to collapse back over there. So now we have something like this. And so from here, you would originally try to reform, right? This is what we call tetrahedral intermediate. So usually when we have tetrahedral intermediates, we reform the carbonyl and kick a leaving group off. But you see how when we do that, we get the same product. So when you do that, and that should tell you that, okay, I need to pronate something. So in this case, okay, we need to pronate something. Let's stop here. You need to pronate or depronate something. And we're going to show these in individual steps, but it's not as complicated. When we say H2O, we always assume it's excess H2O, meaning that we have leftover H2O. So we first start off by depronating, okay? So when you depronate, you're going to get this. And you're probably asking, why do we start off as depronating? And this is due to this being in acidic conditions. Okay, when it's acidic conditions, you can't have an OH group. So let's say that instead of what we did, let's say that we did this, and then this came back here. This would make this group, and this group does not exist in acidic conditions. So we can't do that. So that immediately tells us, okay, we need to take a proton to make this neutral. Remember, everything wants to be neutral. Your oxygen does not want to be positive. So now that we're here, now we know H3O plus is an acid. So now we can then do that there and make that fall. And then that's how you get your product. Okay. There's probably another way to do this again, but this is correct. And yeah, so this is just the formation of hydrates. And this reaction is called hydration, which is very easy. So next we need to go over a general diol and then a visceral diol. So general diols are on the same side. Remember, we could also call this cis, right? And then visceral diol are on different side. So we also call this trans. So pretty much very simple. This is how it looks again, yeah. So cis diol, trans diol, and then syn. When you see syn addition, it means added on the same side. And then when you see anti-addition, added on different sides. Okay, whatever. Okay, makes sense. Yes, yes, it does. So that's pretty much it. This is it for chapter 1.2, alcohols. So next we're going to do chapter 1.3, which is going to be aldehydes and ketones. So see you guys.